In this video, I'm going to show how to use a Bluetooth module to achieve wireless communication between any device that can do Bluetooth with Stelleris board. The Bluetooth I'm using is actually a XComRecv Bluetooth module, which is available online for less than $10. So it has, let me get this zoom. It's not focusing. So you need only two communication lines. Basically, it's a serial device, so you need RX and TX. And beside that, you need VCC and ground to power it up. And that's it. And you just, I'm just a little bit lazy and use onboard power to power this chip because it doesn't draw much current. And I connect UART1 on this Stellaris to the chip to achieve communication. The other part of this communication test is actually my laptop. I'm not sure if you can see it, and now below the white connector there's the USB, not USB dongle. It is USB dongle that does Bluetooth, because my computer doesn't natively have Bluetooth communication. So after you connect this thing up, like the small dongle, this one, and you will see a Bluetooth device icon in your system tray. You can pair the device. By the way, first you have to power up this XComRecv. Just power it up, and there's a light will start blinking. And after you power up, and you can kind of add a device. See, this is add device. I already pair it, so if I do it now, it doesn't show up this. So basically, you get this device in your Bluetooth devices list. And after that, if you want to take a look at your device manager, open up device manager, you will see this port, like standard serial over Bluetooth link. For some reason I'm getting two, I don't know why, but actually only this COM10 is usable for me. So that basically say, if you write anything to COM10 on this computer, it will be wirelessly transmitted to this device and then through this line back to the Stellaris chip. This is the hardware setup. On the software side, I make some modification of this originally of this MPComRecv block, and I make a new one called XComRecv. Basically, MPComRecv just receive data from the virtual port, which is multiplex on UART0, and this XComRecv is actually receiving from UART1, which is a hardware port. It's not multiplex at all. So here's a demo block, demo diagram I made. Basically, this is the block I made, and so since it's always using UART1, it doesn't let you to set a port name, but you still have to set up the package size. And since this time this block is operating hardware directly, so you have to specify the baud rate as well. And no wonder you have to specify the sample time to tell it how fast it should be sampled. And basically the rest of it is just the same as the old MPCom port receive. So after you receive it, you connect to the on-pack, which is a block that comes from XPC target, and here I can just use it. It's already ready to use. So after that, I minus the. Oh, by the way, I have to say, assuming our pack structure is just like as simple as this, so I'm just setting 1 byte over. So here, as I specify, it's 1 byte. as well. And in the unpack, it's unpacked to 1 byte, unsigned in 8-bit, and this output of that, and subtract 48, which is ASCII code for 0. And if it is 0, I output 0 from this multiplex. If it's 1, which is ASCII 1, I'm output 2. And otherwise, I'm just repeating, just basically it's latched data, no modification of data. And this is then sent to the GPIO output for displaying LED. So this basically achieve remote control of the onboard LED. Let's see how it works. So I'm using PuTTY to connect to the UART. Sorry, not UART, but to the COM port. So I select serial, and remember it's COM10, and by default it's 9600 baud rate, and okay. By the way, I already downloaded this program to the Launchpad, so it's already running. Remember, if I press 1, then the LED will be the GPIO port will get in 2, so you basically light up the red LED. If I'm tapping 0, and you can see the LED is off. So this will achieve our communication. Let's just make sure I didn't do any tricks. So 1, 0, 1, 0. Okay, so look like it's already working. One thing to note is just like MP port receive, so this thing have a sample time. If you don't retrieve the data, which means you don't sample the data fast enough, and you're sending the data to through Bluetooth too fast, you end up ruining your buffer. So this doesn't make much trouble if you just have 1 byte. If you have multiple byte structure, like a data structure, actually you will see like the package being corrupted, and because it's not that smart. After it's corrupted, it can't sync back as find its sync anyway. So don't do that. Just sample fast enough. Here it is. That's it. Thank you for watching.